Okay, it's time. We are already 27 participants, and I would like to welcome all of you. This is kind of trial. We will try Zoom for the first time in a colloquium. We hope everything will work out. And we will have the presentation from our colleague, Dr. Alisher Mirzabayev, who works at CEF since 2012. No? He has worked in several regions, and he has also worked in many areas. He has expertise in many areas. And today he will present us the impacts of extreme weather events and their changing climate on household consumption and assets inequality in Uganda. And just before he starts a clarification, I am under the name Eva Yukana because it's her account, but my name is Denise Avilés. We know each other with many of you already. And how it will work today, like every colloquium, we will have the presentation, and after that we will have some questions and answers session. Yeah. So please, Alisher, the screen is yours.
Thank you, Dennis. Thank you, everybody, for joining this seminar today. As Dennis said, I will talk about my ongoing research on the impacts of weather extremes on economic inequality. I will focus on such weather extremes as droughts and floods, and use Uganda as the study country. So let me change the slide. Okay. That works. There is now a considerable amount of literature showing that climate change is already increasing the scales, the intensity and frequency of extreme weather events. We know that people, households, and communities have different exposures, different vulnerabilities and adaptive capacities to any shocks that they experience, including extreme weather. And droughts will affect much stronger already poor smallholder rain-fed farmers than, say, public sector employees. So this differentiated impact of weather extremes can raise inequality, first and foremost economic inequality, which I study in this paper, but also social inequality in the longer term, affecting access to education, to health services and others. We cannot avoid some level of inequality. Why we are concerned about inequality then? Because high levels of inequality reduce economic growth, hinder sustainable development, and many developing countries already have high levels of inequality. Already poverty and degradation of the natural resource base in developing countries are concentrated in fragile, marginalized, and climate change prone areas. And what's more, institutions and safety nets that help alleviate the adverse impacts of weather extremes are weak in many developing countries. There is growing literature on how weather variability and climate change affect inequality between countries. There are many causal channels suggested for that, such as varying dependence on climate-sensitive sectors. For example, share of agriculture in high-income countries is less than 5% of their gross domestic products. But for many lower-income countries, this is more than half of their GDP. Other potential mechanisms include impacts on labor productivity, on health, on market volatility and conflicts. But there is practically no literature, I could cite only a couple of papers, about the impacts of weather extremes on within-country inequality. And what is important here is to have a rigorous attribution of these inequality changes to extreme weather, separating them from underlying structural sources of inequality prevalent in any given country. The intention of this study is to provide inputs to this lacking strand of literature on how inequality inside one country is changed by extreme weather. I seek to answer two research questions using Uganda as my study country. First, does exposure to extreme weather events affect consumption and asset-based inequality? And second, how can public policies alleviate the impacts of extreme weather events on economic inequality? The conceptual figure presented here illustrates the complexity of attributing the impacts of extreme weather events on economic inequality. Extreme weather events affect crop yields and through them local food prices. especially when local food markets are not well linked to international food markets. Since majority of households in Uganda derive at least a part of their income from agriculture, and many are semi-subsistence households, crop yield declines will affect their agricultural incomes and also their food consumption. Shortfalls in agricultural incomes can push affected households to seek out non-farm work, remittances from friends and relatives, or demand public transfers. Another frequent way that households affected by income reductions employ to smoothen their consumption is by selling their assets. So all these causal processes can ultimately have influence on economic inequality, along with other factors affecting inequality, such as differentiated access to education, markets and infrastructure, and access to public resources. So these are more structural drivers of inequality. The data set used in the analysis comes from the Living Standards Measurement Study, Integrated Surveys on Agriculture, so from the World Bank for Uganda, done in Uganda. The survey is representative at the national level, includes both urban and rural households. In this analysis, the 4 wave survey data were used to form a balanced panel of 2,053 households. So that means that we have consistent data on the same more than 2,000 households from 2006 till 2012. So the rainfall and temperature data were taken from World Clim Database and United States National Oceanic and Atmospheric Administration. This household survey data set spans a 6-year period of time with highly varying rainfall conditions, as you can see in this slide. The 2006 wave fell on one of the driest years ever recorded for Uganda. 2010 wave was during an average rainfall year, while 2011 and 2012 waves were during the wettest years on record. These are, and here now you can see highlighted in red circles. This feature of the datasets provides a natural experimental setting, contributing to the more rigorous attribution of the effects of extreme weather events on economic inequality. This is also shown by the household-specific rainfall values. When we extract rainfall data for each household location, we again see that 2006 was a very dry year, 2010 had more rainfall, and 2011 and 12 had even higher amounts of rainfall. And this was consistent for both households who reported to have experienced extreme weather events and those who reported having experienced no extreme weather events. Although it's true that those who did not report extreme weather events here, they are given as blue line, were more closely clustered around long-term mean values. That means normal values, so quote unquote, while those who did report extreme weather experiences here in red, had more extreme values of observed precipitation. Meaning that self-reports of extreme weather events in this case were broadly consistent with actually measured precipitation levels. If you look into this from a spatial perspective, there's no visible pattern. So it shows from longitude and latitude, and there is no pattern or special clustering of these experiences of extreme weather events. In many areas, some households reported being affected by extreme weather events, while some others residing in the same area were not affected. So this corroborates the conceptual thinking I was talking about earlier. Even when exposure to hazards is the same, people are affected differently because they have different vulnerabilities and adaptive capacities. So the table here shows average characteristics of households depending on the reporting of extreme weather experiences. It shows a clear pattern of those households who have been more often affected by extreme weather events, having lower total assets, lower consumption of food and of durable and non-durable items. Here, food consumption values include also the value of home-produced food. An important distinction between these 3 categories of households is access to other income, meaning non-agricultural revenues, remittances, and public assistance. Those households which are more affected by extreme weather events have less income coming from outside agriculture. There are no tangible differences between the groups on their level of education. Now, coming to the methods, the major issue that needs to be addressed by the estimation technique we want to employ is that households' self-reports of weather extremes may be unreliable because of misperception. And these perceptions may be also influenced by other household characteristics that cause inequality, which we don't or simply cannot include in the model. For example, people's abilities are different. Someone may be more hardworking, someone is less, someone has more aspirations, someone has less. So many such things that may affect the model. If we don't control for all these important characteristics, our model results may be inaccurate or outright wrong. But we cannot control for all of these explicitly. One of the best approaches available to us when we have the panel data is using the household fixed effects, which allows us to purge the model of the influences of unobserved time invariant characteristics. So I used a Hausman test to check if an alternative random effects panel model was more suitable. And the test clearly indicated that fixed effects model was more appropriate in this case. Also, to avoid any indigeneity issues, I used the actually observed rainfall data, which is exogenous to household characteristics, as an alternative to household self-reports of extreme weather event experiences. The dependent variable is either Gini index of the value of total consumption or the Gini index of assets owned by households. Gini index is a standard measure of inequality, showing here in our case the distribution of the value of assets or value of consumption calculated at the district level. It varies theoretically from 0 to 1. 0 means absolute equality between all households. 1 means one household has it all and all others have nothing. The vector of independent variables includes household self-reports of experiences of extreme weather events, yes or no dummy here. And alternatively, observed precipitation, so actually measured precipitation shortfalls during the survey year compared to long-term mean precipitation. By a long-term mean, here I mean the average for the period 1960 to 1990. And other variables, explanatory variables that you can see on the slide. So now these are the main results. 4 models with household fixed effects panel regression are given here. Models 1 and 2 have consumption Gini index as their dependent variable. The difference between them is that model 1 has actually observed precipitation shortfall from long-term mean as an independent variable, while in model 2, this is replaced by households' own reports of being affected or not affected by extreme weather events. Model 3 and 4 have assets Gini index as their dependent variable. Similarly, model 3 and 4 use either actually observed precipitation shortfalls or household self-reports. Here, these variables are given in yellow and blue colors on top of the table. Both self-reported experiences of extreme weather events and exogenously observed shortfalls in that year's rainfall from long-term mean have mutually consistent impacts on consumption and assets Gini indices. Both reduce the consumption Gini index and increase assets Gini index. So marginal effects analysis show that about a 10% shortfall in the annual precipitation compared to the long-term mean resulted in a 0.05%, 0.05 points higher assets Gini index. So to put it into context, the average consumption and asset-based Gini indices were 0.36 and 0.66 for this surveyed households. So 10% shortfall in annual precipitation can lead to 0.05 points higher assets Gini index, while self-reported experience of extreme events resulted in 0.03 points higher assets Gini index. So on the other hand, self-reported exposure to extreme weather events slightly reduced consumption Gini index by 0.01, and 10% shortfall in the annual precipitation reduced consumption Gini index by 0.02. So just to give a big, broad picture of what it means, it shows that the weather extremes can change the Gini index consumption or set Gini index by something up to 8%, so from 3 to 8%. If I'm comparing in, as a percentage of those overall Gini indices that I talked about earlier. We can also see that application of sustainable land management practices here, meaning terraces, gabion, tree and grass belts, were found to have increased asset Gini index by about 0.02 points. So larger household size was consistently found to be linked to lowering both consumption and asset Gini indices. Higher values of agricultural sales by households led to lower asset Gini index, but no statistically significant effect on consumption Gini index. So the slight decrease in consumption inequality following extreme weather events is likely to be due to consumption smoothing by households at lower end of food consumption, and some consumption reduction by those households who had higher levels of initial consumption. So the survey data shows that households reported that major coping mechanisms were through using savings, getting non-farm jobs, and seeking assistance from friends and relatives and local government. Consumption reduction may have contributed to lower consumption inequality, since at the low end of the consumption, when people are really poor and food insecure already to start with, there's not much space for further reductions. So these consumption reductions may have come from households with higher levels of consumption. Some coping mechanisms remained consistent across the years, while some others evolved between 2005 to 2011. Savings and getting help from friends, relatives, and governments have consistent shares in the coping mechanisms. On the other hand, the use of consumption reduction, so people are simply consuming less, eating less, selling assets, and getting non-farm work as coping mechanisms is declining over this period. Since affected households are using up their savings for coping with extreme weather events, they have lower funds available for building up and replacing their assets, which is resulting in higher asset inequality. So coming to conclusion, so the results show that extreme weather events have significant, both statistically significant, and I also think economically significant impacts on consumption and asset-based inequality in Uganda. Extreme weather events were found to reduce consumption inequality while increasing asset-based inequality in Uganda. So in this context, what the government can do, what are the policy implications? So to increase resilience against extreme weather events, government needs to facilitate savings, generate non-farm jobs, deploy more widely weather insurance and safety nets, and promote agricultural commercialization. So these are my major findings so far. As I said, this is research which is in process, so I would be very much grateful for your comments, suggestions, and questions. Thank you.